3-eye atlas updates, and maybe even our best shot yet to clearly see the third interstellar object ever detected passing through our solar system.
Tonight, the solar system holds its breath. Across mission control centers from Pasadena to Darmstadt, every screen shows the same blinking target, 3I/ATLAS, the third confirmed interstellar visitor in human history. It's racing toward Mars at 0.19 astronomical units, roughly 28 million kilometers away, on a trajectory that cuts straight through the red planet's orbital lane. What began as a faint blur in an amateur telescope months ago is now a fully fledged cosmic event. Every active orbiter around Mars, MAVEN, Mars Express, ExoMars TGO, is locked on. Observation teams are running emergency protocols. The clock ticks down to a 6-hour blackout, the moment Earth will lose direct visibility as the object swings behind the sun. When that happens, Mars will become the only eye left open in the solar system. It's not just another comet flyby. It's the first interstellar encounter ever recorded inside another planet's orbit, and the stakes have never been higher. Inside NASA's MAVEN Control Center, the tension feels electric. The so-called Red Watch crew, a small, hand-picked team of engineers and mission specialists trained for critical events, has been on shift since dawn. Their task: run synchronized observation drills for a visitor no one fully understands. The main screen flashes telemetry from all Mars orbiters, data streaming through overlapping windows of time before the signal blackout. In the final hours, they rehearse burst mode spectroscopy, rapid switching between wavelength bands to capture every possible spectral shift. Backup systems are online, secondary logs rolling. Every byte of data is duplicated and transmitted twice through separate channels. No single point of failure is acceptable. The team works in near silence, except for the crisp cadence of checklists. Packet verified, relay path green, next sweep in 30 seconds. Every probe's timeline is pre-scripted to the minute. MAVEN will focus on ion readings, Mars Express will capture broadband imaging, TGO will map trace gases. Yet even with the precision of international coordination, no one knows what to expect once the comet crosses Mars's orbital shadow. "We're blind in 6 hours," the operations director reminds them. After that, it's up to Mars. Across the room, someone adjusts the comms gain and mutters, "We only get one pass." That sentence hangs in the air like a warning. When Earth loses sight, Mars becomes the only witness, and whatever 3I/ATLAS does in those hours will define the next decade of planetary science. But the real story didn't start here, in mission control. It began months earlier in a small apartment balcony in Pune, India, where amateur astronomer Priya Rai was scanning the pre-dawn sky through her modest backyard setup. Among routine exposures, she noticed something odd, a dim object whose brightness rose and fell in precise, repeating intervals. Not random flickers, pulses. Intrigued, she logged the data and shared it on a global astronomy forum. Within days, observers from Europe and South America confirmed the pattern. The light curve showed machine-like regularity, a rhythmic cycle that persisted over multiple nights. In comets, brightness fluctuates as sunlight strikes uneven surfaces, but never this consistently. The phenomenon caught the attention of professionals at the Minor Planet Center and eventually NASA's Near-Earth Object Program. What began as a curiosity was now an anomaly under official watch. As more telescopes joined the campaign, the puzzle deepened. The periodic brightening matched no known outgassing pattern or rotational signature. Instead of fading with distance, the rhythm held steady, Clean onsets, uniform decay, almost like a coded beacon. Data analysts described it as measured pulses synchronized across observation points thousands of kilometers apart. By September, the discussion shifted from odd behavior to a more daring question. Could the source of those pulses be deliberate? No one dared to claim intention, but the phrasing crept into technical reports. Internally modulated, non-random periodicity. Now, as 3I/ATLAS closes in on Mars, the hope is that the flyby will either prove those signals natural or open the door to something much stranger. And then there's the light. Atlas glows emerald green, an unmistakable hue peaking at 516 nanometers, bright enough to be captured even through the Martian haze. Standard comet chemistry explains most colors, carbon compounds, ionized gas, or cyanogen, but this one defies the models. The C2 swan bands don't fit, nor do carbon monoxide emissions. The carbon dioxide to water ratio is off the charts, 8:1, 10 times higher than any comet recorded. Add to that another twist. Nickel dominates over iron in its spectral lines, a complete reversal of the natural abundance seen in solar system material. For weeks, scientists tried to reproduce the readings in laboratory simulations. None matched. The numbers make sense only if the surface or subsurface is metal-rich, not icy. One team at the James Webb Space Telescope suggested that the composition might resemble forged alloys, not mineral mixtures. That hint alone transformed the conversation from astrophysics to speculation. The European Space Agency's TGO spectrometer confirmed the findings independently. Its readings showed concentrated nickel vapor, cyanide traces, and sustained carbon dioxide jets, ingredients more common in industrial chemistry than cometary geology. Together, they formed a picture of an object that shouldn't exist in nature. As one scientist put it during a private briefing, if a comet looked designed, this would be it. Meanwhile, precision tracking from the Harvard-Smithsonian Center for Astrophysics revealed another clue: the trajectory's subtle deviations. These weren't wild swings, but micro-accelerations, gentle course corrections measured in fractions of a meter per second squared. Each coincided with a brightness pulse, as if the two phenomena, light and motion, were linked. In a natural body, outgassing is chaotic, throwing the object slightly off course. But Atlas's nudges were consistent in direction and magnitude, like small adjustments guided by control. Analysts began calling it the engineered behavior problem. Inside NASA, the phrase appeared in cross-team memos between propulsion specialists and astrochemists, sparking quiet debate about what could produce such precision without active thrust. Dust models offered no comfort. High-resolution imaging from Mars Express showed particles drifting not in chaotic jets but in broad, slow arcs, their dispersion symmetrical and measured. It looked less like an explosion and more like a controlled venting process, timed with the same rhythm found in the light pulses. Some even speculated that these arcs could represent vent arrays or directional plumes, releasing material in balanced bursts to maintain stability. For now, no one has definitive proof, but the evidence keeps stacking. A rhythmic pulse, metallic composition, synchronized micro-accelerations, and a green glow that refuses to fade. The combination suggests something active, not passive, a system reacting, adjusting, perhaps even responding. Back at Mission Control, countdown clocks flash red as MAVEN's instruments recalibrate for high-frequency sampling. Window opens in 5 minutes, the flight director says. Operators steady themselves. This is it. The first interstellar object ever to pass so close to another world. The first moment Earth must rely entirely on robotic eyes millions of kilometers away. Outside, Mars turns slowly beneath an alien visitor that no one can fully explain. Whatever happens next, every camera, spectrometer, and sensor will be watching. Because in the next few hours, 3 I/ATLAS could either confirm the limits of natural physics or reveal that those limits no longer apply. If you're following this story and want to see what MAVEN and Mars Express capture in real time, make sure you're subscribed. We'll break down every new image, every signal, and every anomaly as they arrive. For 6 hours, Mars became humanity's only window to the cosmos. With Earth eclipsed behind the Sun, every instrument orbiting the red planet was pushed to its limit. 3 I/ATLAS swept past at 0.19 astronomical units, glowing bright green against the black, and every probe in Martian orbit turned toward it like synchronized eyes in the dark. The MAVEN spacecraft ran in burst mode, its ultraviolet spectrograph tuned to catch even the faintest hint of ionized gas. Teams hunted for ripples, shocks in Mars's upper atmosphere that might betray an electromagnetic wake or an active energy discharge. Meanwhile, Mars Express cycled through high-speed imaging sequences, stacking broadband exposures every few minutes to catch any sign of tail fragmentation or restructuring. The ExoMars Trace Gas Orbiter, TGO, switched its focus from routine methane studies to scanning for isotopic ratios in carbon and oxygen that might hint at non-terrestrial chemistry. On the surface, NASA's Perseverance rover and China's Zhurong joined the effort as silent sentinels, monitoring the Martian sky for faint auroral glows, dust fallout, or magnetic shifts, anything that might signal interaction between ATLAS and the planet's thin atmosphere. During 3 I/ATLAS's closest pass to Mars, MAVEN detected rhythmic ionospheric waves matching the comet's brightness pulses, sparking confusion among engineers and scientists. Data from Mars streamed non-stop through redundant networks, verified by dual NASA ESA teams to prevent any corruption. Planetary protection officers enforced strict containment for any captured particles, ensuring full transparency and public release of all data. As results arrived, 4 main theories emerged: ultra-cold chemistry from deep space, layered gas pockets releasing rhythmic jets, dust dynamics producing smooth arcs, and the idea that current comet models are simply incomplete. None fully explained Atlas's precision, leaving scientists torn between natural complexity and the possibility of something far stranger. Each theory answered part of the mystery, but not all of it. None explained why Atlas's brightness pulses remained perfectly synchronized with its micro-accelerations. None accounted for the metallic signature, nickel vapor without iron, or the peculiar stability of its orbit near Mars. As tension grew, Harvard astrophysicist Avi Loeb warned in a press briefing, "When you eliminate every natural cause, what's left might not fit in our textbooks." NASA's Jet Propulsion Laboratory quickly countered, reminding the public, unusual does not equal unnatural. But behind the scenes, even conservative scientists admitted privately that ATLAS had crossed into territory beyond precedent. Inside the Red Watch headquarters at MAVEN Control, a laminated sheet hung above the main display. 3 words in bold red: conservative, hazardous, extraordinary. This was the decision matrix, a live document guiding every mission verdict. Conservative meant the data still aligned with known comet behavior, even if rare. Hazardous triggered contingency mode, immediate instrument safing if mass loss or debris fields threaten the orbiters. The final category, extraordinary, demanded something far stricter. 2 independent, statistically significant anomalies confirmed by separate teams. No single sensor could justify it. It had to be convergence, brightness pulses matched by micro-accelerations, or isotopic ratios that defied chemistry across instruments. Only when 2 unrelated phenomena aligned could the label extraordinary move up the chain. Every operator knew the gravity of that classification. One confirmed event could reshape how humanity defined interstellar science. As the 6-hour window unfolded, the decision matrix became their lifeline. MAVEN logged 3 sustained brightness surges paired with faint magnetic fluctuations. TGO registered carbon isotope ratios slightly offset from solar norms. Mars Express, meanwhile, captured a strange widening in the tail's arc geometry, as if the object's jets had shifted direction mid-flight. The Red Watch team debated in hushed voices whether the data cleared the extraordinary threshold. They didn't rush. Verification demanded precision. Every frame was cross-compared, every anomaly time-stamped and matched. When the final packet came through, 40 hours after the first pass, the room erupted in cautious applause. They had done it. No signal was lost, no instrument compromised. The archive contained terabytes of clean data, spanning ultraviolet, infrared, and magnetic readings. But celebration quickly gave way to quiet disbelief as the early composites rolled in. The emerald glow remained unwavering. The CO2 surges tracked in perfect rhythm with the brightness pulses, and the nickel lines still blazed brighter than iron. Natural models could explain fragments, but not the consistency. True to the new protocol, the agencies released everything. Within 12 hours, raw data from all Mars orbiters went live on open servers, accessible to researchers and amateurs alike. It was an unprecedented gesture of transparency and a recognition that whatever Atlas was, it belonged to human knowledge, not secrecy. Across the globe, astronomers downloaded the data, running their own analyses through home-built models. Forums and think tanks buzzed with theories. Was it geological, engineered, a remnant of something ancient? For all its revelations, the Mars flyby left the biggest questions unanswered. Why did 3 I/ATLAS move with such precision? How did it maintain its rhythm under solar radiation? And why did its chemistry look forged rather than frozen? Over 40 hours of continuous data yielded one undeniable truth. This interstellar object wasn't like anything ever seen before. Every known physical law could describe a fragment of its behavior, but never the whole. And as the final transmission from Mars faded into static, a single message from the Red Watch log summed up the night. Observation complete. Classification unresolved. Awaiting reappearance. For the scientists who witnessed it, that meant only one thing. 3 I/ATLAS had passed Mars and left behind a mystery that might take decades to solve.